This is the Unit 3 Study Guide Circle video. Unit 3 Study Guide Circle video. I recommend you have your ringlet handy, colors, and a calculator. Taking a look here, here's your study guide. This is going to be due for A Day. It is due on October the 31st. That's for A Day. And for B Days, it's going to be due on November the 1st for B Days. You should be able to fill all of this out completely from memory. And let's now work through some of these circle videos. About a third of this is going to be review. So it says review using intercepts or change to slope-intercept form and graph. So we want to take here, and I'm going to use both here using intercepts. I'm going to go 0, blank, and then blank, 0. 0, blank, so a 0 in the x means we say goodbye to the x. So I end up with negative 3y equals 9. And we solve, divide by negative 3. And we end up with y equals negative 3. The other method, we're going to put a 0 in the y. So if we come up here and we say goodbye to the y, I end up with negative 9x equals 9. And we see that our x-intercept is going to be negative 1. So let's graph this. 0, negative 3. It's right here. And negative 1, 0 is right here. To change this to y equals mx plus b, if that's what you prefer, let me come over here. We have negative 3y minus 9x equals 9. Start by circling y. Your goal is to get y all by itself. So let's get rid of this term. So we're going to go positive 9x plus 9x. Next line reads negative 3y equals 9x plus 9. Divide by negative 3. And we get y equals, negative 3 goes into 9 3 times, so I have negative 3 over 1, x minus 3. Now, if we were to graph this, you start at the negative 3 for the y-intercept, which we already have, and it's a down 3 over 1, so down 3 over 1, or you can go up 3 over 1 to the left because it's negative. Either way, you're going to get the exact same line. So if you look, the intercepts work and solving for y works. There's your line right there. Okay, distance equation. Find the distance. Let's write the distance equation here. Distance equals giant square root. You're going to subtract the x's squared plus subtract the y's squared. If you were to look this up, it'd say x2 minus x1 equals y2 minus y1. You really don't need to worry about that. Just make sure you subtract the x's, subtract the y's. When you work with the distance equation, I always want you to start with a template. The template is the blank version of the equation, just minus the x and the y. That is a template. let's come here. We have x's, so I'm going to circle my x's, and I'm going to plug them in left to right. Negative 12, negative 10. And I'm going to box my y's and plug them in left to right. 7 and negative 1. You could have gone right to left as long as you're consistent. Okay, now you just have to watch out for double negatives. This is a double negative, becomes positive. Double negative becomes positive. So now we do negative 12 plus 10 is going to be negative 2 squared. 7 plus 1 is 8 squared. Negative 2 times negative 2 is positive 4. 8 times 8 is 64. So my answer is square root of 68. If I want exact terms, or if the test asks for exact term, root 68 is fine. If it says you can have a decimal or round to the nearest tenth, you just do 68 and square root, and we get 8.2. So that's approximately 8.2. So it's very important when you work with the distance equation that you always write out the distance equation and then the template first thing. Here it says write the slope-intercept form of the equation of the line described. So we have a described line. Then graph both the given line, there's going to be a given line, and the described line on the graph. So we're going to have two lines here, a given line and a described line. I'm going to do the one on the left. So on the left, our given line is this. So let's go ahead and try graphing that. It's y equals mx plus b. So our b is going to be negative 5. And our slope is positive 2 over 9. So we go up 2. There's 9. Or you can drop 2 and go over left 9. Okay, so this is your given line. Now the described line has two qualities. The described line is perpendicular to this line and goes through this point. So we want to write y equals mx plus b. And you ask yourself, what is it that you need for this equation? We need an intercept and we need a slope. Now we want it to be perpendicular to here. So let's write our equations out, what we know about slope. For perpendicular lines, we know that the slope times the slope have to equal negative 1. For parallel lines, it's slope equals slope. That you should have memorized. So looking here, our slope that we're given is 2 over 9, and we want it perpendicular. So I come down here, and I do 2 over 9 times something equals negative 1. And I need to figure out what that something is. And you should see to get negative 1 there, it's just the opposite reciprocal. So it's going to be negative 9 over 2. So that is your desired slope. That goes right there. Now we also need an intercept. Problem is we don't have it, so we're going to call it b. But we do have a value of x and y. X is going to be -2. Y is going to be +4. Now we solve for b. Put this over 1. So we see 2 goes into 2 here one time, and I still have a -1 there, so be careful you don't drop the negative. Next line reads, 4 equals -9 times -1 is +9 plus b. We're going to minus 9, and we have b equals -5. Now our equation is y equals mx plus b. So we have y equals our new slope, which is -9/2, x plus our new b, which is going to be -5. Now let's graph that desired line and see if it works. So we're going to start at -5. And we know it's a negative, so it's going to go down from left to right. So I can go down 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and over 1. Or I could go up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Whoops, it's over 2. And over 2, notice it's a negative slope. Okay, let's graph that. There was your intercept. Okay, so 1, they should look perpendicular, which they do. 2, we want it to go through -2, -2, +4, which is right there. So our desired line does both. 1, it's perpendicular to the given line, and it goes through the point. Okay, next one, slope and midpoint. Slope, put this in the margin, you need to have this memorized, equals rise over run. And to find the rise, you subtract the y. So it's y minus y over x minus x. Rise, wise. Rise, wise. So you're going to do y minus y over x minus x. That's slope. Now the slope template looks like this. So I just write slope equals, and I'm going to make a blank template. The most important thing to remember is y goes on top because it's the rise, which is up and down. So I box my y's, and I'm going to subtract left to right. So I have 0 and 10 here. Circle your x's and subtract left to right. So I have 17 and -10. That's why it's important to have a template. That way you catch the double negatives. 0 minus 10 is simply -10. 17 minus negative 10, this becomes positive, that's 27. You see if you can reduce, which you can't here, so your answer is negative 10 over 27. So slope is rise over run, rise subtract the y's over run subtract the x's. So find the midpoint of a segment with the given endpoints. So both of these are end points. And to find the midpoint, all you do is you average the x's and you average the y's. The equation looks like this. X plus x over 2, comma, y plus y over 2. I'll wait for you to catch up and get that drawn. So you want to start with the template. Okay, that is your template. So now we're going to put our x's in. So I circle my x's and I plug them in. So I have 8 and negative 8. I'm going from left to right. Here I box. Go left to right again. Negative 10 plus positive 10. If you take a close look, that's 0. 0 over 2 is just big fat 0. That's 0 again. 0 over 2 is 0. And that's now our midpoint. What's really nice is it's easy to kind of just do a little quick sketch of these, and you should be able to see pretty easily whether or not you're correct. So let's just do a baby quick sketch. Our first endpoint was 8 and negative 10. So if you were to go over 8, down 10, there it would be. That's 8, negative 10. And the other one is negative 8, positive 10. So negative 8 would be this way. Positive 10 would be way up here. And now we're claiming the midpoint is right here at 0, 0. If this were a test, I'd make sure the graph is very accurate. But you can see, yeah, 0, 0 looks like the midpoint. And mathematically it is. I get some colors for the next problem if I were you. If you have some colors, that would be great. Okay, if you're wondering what this symbol is here, it is my symbol for what I call, I don't know if you can read that, but it's no naked diagrams. When you work with diagrams in geometry, they need to be labeled. You need to, when things are equal, you need to mark it. When you're doing angles, trace and sweep. When things are parallel, stretch it out. You should be really marking up the diagrams. No naked diagrams. Let's do this real slow. I'm going to use 3 different colors. It says find the measure of SJK. So with one color, I'm going to go like this. SJK sweep, and that's my question mark. That's what I want to find. I'm given the measure of IJK is 162. So I'm switching colors, and I want IJK. So start at I, go to J, go to K, and we sweep. That means all of that is 162 degrees. Don't assume it's 180 unless you're told it's a straight line. What else are we given? The measure of IJS. So we start at I, go to J, go to S, sweep, that's 140. And your ambition is to find that blue. Well, you should see right off the bat, just physically trace this with me. If from here to here is 162, and here to here is 140, what would that be? And what would you do to find it? Hopefully you see that all you do is you take the purple and subtract the red. So our purple is 162. We're going to minus the red, which is 140. And that's going to give us the blue. This is 2. That's 2. That's 0. So we know here that the measure of angle SJK equals 22 degrees. Okay, it says find the other endpoint of a line segment given an endpoint and a midpoint. Now be careful with this. Do not immediately stick it into the midpoint equation. Let's just do a visual. It's easier to do this if you simply have a visual and you label everything first. So just draw a quick sketch here. That's why I left you lots of space. So I have one endpoint here, and that is -6, +3. So I'm going to go -6, 1, 2, 3, 4, 5, 6, +3, 1, 2, 3. There's a dot, -6, +3, and make sure you label this is an endpoint. Our midpoint is at -9, -4, so -9. 1, 2, 3, 4, 5, 6, 7, 8, 9, and -4. 1, 2, 3, 4. There's our midpoint. So that dot right here is a midpoint of something. So what we have going on here is we have a segment which from that blue dot to the red and the red to another mystery endpoint which we don't know, this one, the other endpoint, that red has to be in the exact middle, but we don't know this other endpoint, but we do know it's out this direction somewhere. So that's our unknown. There's two ways to do this, algebraically and then logically. Let me show you the algebra first. Algebra, remember to get the midpoint, we added the x's and divide by 2. We add the y's and divide by 2. But the trick here is we cannot take these two numbers, add and divide by 2, because that 9 there is the midpoint. Is an equal sign. So that's -9. And -4 goes on this side. Then here we have -6, that's our x coordinate, plus our mystery x coordinate. And then the other one here is going to be 3, our y's, plus mystery y coordinate. So that's how you would set up the algebra. Now you just put it over 1, cross multiply. For those of you like algebra, you use your equation there, but keep in mind you have a midpoint. So that means the midpoint equals 9 and equals -4 separately, and you would solve for your x and y. Another way, logically, you can do this is if we go from -6 to -9. Let me just do my x-coordinates. I'm moving from -6 to -9. And you ask yourself what that distance is. And we know the distance is 3 units. Okay, you're not adding, you're just finding the distance. That means, and 9, remember 9 is the middle point, so it's the middle. So then I ask myself, if I were to go 3 units this way to my other mystery x, where would I be? And notice, I know it has to be negative, so if I go -9 and I march to the left 3 more units, I know my answer is going to be -11. Let's try the y-coordinate. The y-coordinate, we start at +3 here. And we go to -4, so we're going to the left. We ask ourselves how many units between that, and because we passed 0, 3 to 0 is 3, and 0 to -4 is 4, so technically this is 3 plus 4, so we have 7. And then if I took and I marched 7 units to the left, where would I be? That would be my new y-coordinate. So -4, marching left 7 units, I'm going to end up with -11 as well. So my mystery coordinates are -11, -11. Now, let me show you how to do a check. So we're saying my endpoint is -6 and 3, and my other endpoint is -11, -11. Those are my endpoints. Let's put them into the distance equation. X's, Y's. Add the x's, divide by 2. So -6 plus -11 . You know what? That's not 11, that's 12. Excuse me, that's why we check stuff. That is 12. -9, march to the left 3 units is going to be 12. So that's -12. That's going to be -18 over 2, and there you go, -9. That's why you check stuff. And then here, let's check this one out. We end up here with, that's going to be -8 over 2. And we end up with -4. Check, it matches. So our other endpoint is -12, -11. If you were to do this algebra up here, cross multiply, you'd end up with the exact same thing. I'm not going to give you an example of solving proportions. You should be able to do that no problem. It says, trace the corresponding positions with 2 different colors and color code if possible. Set up a proportion to solve for x. Let's take a look at this one. So I'm going to use 2 different colors. So I'm going to go short side to short side. Then we're going to color code long side to long side. So color code your sides and make sure they're in the same position. Now I'm going to set up a proportion. It doesn't matter whether I go 9 to 15 or 15 to 9. What does matter is you stay consistent. I always go left to right. So I'm going to go 9 to 15 equals 24 to 4x plus 8. So I have 9, 4x plus 8 equals 15 times 24. Distribute. 15 times 24, I'm going to do up here. 4 times 5 is 20, carry the 2. 4 times 1 is 4, plus 2, that's 60. 2 times 5 is 10, carry the 1. And that's going to be 3, so it's 360. Now we minus 72 both sides. $36x equals 2 from 10 is 8. 7 from 15 is 8, so we have 288. Divide by 36. So we do 288 divided by 36, and we get 8. Let's see if that actually works. 4 times 8 plus 8. That's 32 plus 8 equals 40. So let's check our ratios here. 9 to 15, 3 goes in here 3 times, 3 goes in here 5 times. 24 to 40, 8 goes in here 3 times, 8 goes in here 5 times. There's your check. Always take a moment and check your ratios, see if they work. Okay, so it says, note the scale factor provided and the direction notes between the polygons. The polygons in each pair are similar. Find the missing side length. Okay, taking a look at 21. It says the scale factor is going from A to B, 2 to 3. So we circle A, we go to B. That's a 2 to 3 ratio. So always just make sure you circle and you figure out which way your ratio is going. So I'm going A to B is 2 to 3. And then I'm going to go unknown to 12. Cross multiply. The key to multiplying is not multiplying, it's reducing. You solve faster that way. So x here equals 8, or your unknown. All right, so it says here, note the given, the implied, and freebies. State if the triangles in the pair are similar, so they might not be similar. If so, complete the similarity statement with the corresponding similarity triangle. Also state what the shortcut is. Angle, angle, side, or side, angle, side similarity. If not similar, state not similar. No naked diagrams. That's what that symbol means. No naked diagrams. It means you should be marking your discovery information on the diagram. Okay, so we're going to come here. We're going to find given, implied information, and freebies. So let's check our given information first. Given, we know that's short and that's the long side. That's short and that's the long side. So let's compare those two. So circle the 8 and circle the 56. Let's check out. 8 does go into 56 7 times, so this is a 1 to 7 ratio. Circle 11, circle 77, let's check that ratio out. 11 goes in here once, 7 goes, and 11 goes in here 7 times. So we see right off the bat, I have a pair of side ratios equal and another pair of side ratios equal. It's also given, here's a 69 squeezed between the sides, and here's a 69 squeezed between the sides. They're equal, which means I have a pair of angles. So I see right now, yes, they're similar, so I'm just going to write yes. I'm going to say it's by side angle side similarity. Now, you want to take a look at, make sure you align your vertices here. So I'm going D, E, F. So D is at the 69, so my match is going to be R, then E is short direction, so I have to go short direction, which is going to be Q, and then the long direction, which is P. So you have to align your vertices there. So we have DEF is similar to RQP by side angle side. Follow a similar process of given, implied, and freebies. You want to fill out this blank with the 3 letters of the corresponding letters, and then tell me whether it's side, 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 angle, side, or angle, angle, similarity here, or not similar, depending on the situation. Take a look at page, there's no circle problems here, but I will tell you this. If you have overlapping triangles, do you see these overlapping triangles here? See overlapping triangles? Highly recommend you pull these apart before you work with them. Pull them apart and pull the numbers over. Okay? So pull overlapping triangles apart before you try to work with them. And then ask yourself, walk through the given, the implied, and the freebies, and see if they're similar or not. Okay, so here it says trace overlapping triangles, pull apart, and redraw the smaller and larger triangles. Relabel with the given information, then solve for the unknown. So here I'm going to pull these triangles apart. So for these, I'd like you to get in the habit of pulling them apart. So here, now very carefully relabel stuff. So this, let's do it the long one first. From here to here is 5. Now careful, from here to here is not 5, nor is it 2. If that's 2 and this is 5, that means this right here is going to be 3. This, of course, is 6. Now watch it, careful, very, very careful. This is going to be 6 from here to here, and this is 2x plus minus 6. So this whole side is going to be 6 plus 2x minus 6. Let's clean this up just a little bit because you see the 6's actually cancel. So this becomes simply 2x. Now you can make a proportion and solve for x. I'm going to go left to right. Circle 3 over 5. 3 over 5, left over right, equals left over right. I'm going to let you solve for x there. That's basic algebra. I think you can manage that on your own. So for all of these, I'd like you to trace, pull them apart, and be extremely careful as you do this to get those numbers correct. Now for this one, I want you to get a ruler and extend parallel lines, trace the segments between the parallel lines, set up a proportion, and solve for the unknown. So for this one, you're not viewing it as separate triangles. For this one, I'd like you to focus on the parallel lines. So let's do that by extending the parallel lines first. And now your eyeballs are going to be focused on these pieces here. Okay? The name of the game is match and mirror, match and mirror. Match and mirror. So we're going to make a proportion here. And our unknown is right here. We call that x. So there's a couple ways we could do this. We could go like this. Unknown over, and go left to right, over 8 equals, watch carefully, trace this whole side, that's 18. 18, left to right. Now careful, your 18 does not match with 8, it does not match with 4, it matches with this whole side. So you have to add, and that's going to be 12. Left to right. You could also have done this. Okay? I'm going to trace. You could have done segment over whole. So segment over the whole thing, which is 18, equals segment it should be 8. Segment, which is 8, over whole, which is 12. Excuse me, that is 18. All right, and then you cross multiply, and if you look carefully, you're going to end up with the same thing either way. So this one is going to be 18 times 8 equals x times 12. This one is going to be x times 12 equals 18 times 8, which is the exact same thing for both. Cross multiply and solve for the unknown. When you are done, go back, check your answers, and I want you to check your answers with a red pen. And if something's incorrect, you must go back and redo the problem in red pen to figure it out. To get full credit here, you need to do problems 1 through 46, showing all your work in pencil. Then you correct with a red pen, and everything you get wrong, you must write a note for why you got it wrong. That's 25 points. And then the last one, you do the word problems on the back for another 25 points. This is a total of 50 points.